So welcome to the new lecture, application of KCL, circuit analysis. Okay, so application of KCL is very important and very easy to understand. If we have learned all the concepts of KCL which was taught in the last lecture, then you will face no problem in the application part. Okay, so let's start. See, this is the electrical circuit, okay, where V1 and V2, these are EMF or batteries of the circuit, okay. These are the actually the power supplies, or you may say the active devices which delivers the power through the circuit, okay. You see the sign of this battery, which means this sign, okay. This is positive terminal and this is negative terminal. In the battery you have seen that there will be two terminals, one is plus and the other is minus. Similarly here also, this big line means this is the positive part and this is negative. Now before approaching this circuit, I want to tell you about one thing about the concept of this battery, okay. So many people have many confusion about this battery, okay. This is very interesting thing. Suppose you have purchased a battery of 5 volt, okay, from the market, and it's like the positive and negative terminal, okay. What is the function of the battery? You have to understand that what is the function of the battery. You see, if you have purchased a battery of 5 volt, it means that the potential difference between this terminal and this terminal is 5 volt. Now if you have connected this terminal, if you have grounded this terminal, what do you mean by grounded? Grounded means the potential of this point is 0 volt, okay. The potential of this point is 0 volt. In this case, the battery will work as an elevator or lift, which will lift you to up to 5th floor. You are in the ground floor and the elevator will elevate you up to a 5th floor, which means if the potential of this point is 0 volt and you are using a 5 volt battery, then this terminal will be of potential 5 volt, okay. Similarly, suppose you have purchased this battery 5 volt again, and this time you have grounded this terminal, okay. Grounded means 0 volt. If the potential of this point is 0 volt, then this point, okay, this is plus, this is minus, okay. Now this time the lift will lift you down towards down, okay. The potential will be less. So if this is 0 volt, suppose you are at the ground floor and you are using the lift to go to the basement, this point will be minus 5 volt. So remember the property of this battery, okay. If you are connecting the ground in the negative, it may not be ground, it can be any voltage. Suppose this voltage is 2 volt, okay, and it will lift you up to by 5 volt. So 2 volt plus 5 volt, this will be 7 volt. It depends, but if this is 0 volt, you will be in the 5 volt position, and if the 0 volt is here, then it will be minus 5 volt. So this is the function of the battery. Now one thing, a circuit needs to be grounded, but see in this case no ground is seen, okay. So I am grounding this common terminal. Again I am saying, what is the meaning of ground? Ground means 0 volt. So this point is 0 volt. Now look carefully. If this point is 0 volt, you are using the battery V1 here, right? If this point is 0 volt, this 0 volt is connected to the negative terminal. So this potential will be 0 plus what amount? V1. So this potential will be V1. The potential of this point will be V1. Again I am saying, this was 0, battery of 5 volt, so this was 5 volt. Here the voltage is 0, connected to negative terminal, it will lift you up to V1. So 0 plus V1 means V1. In this case, this was 0, it will lift to V2. So this potential will be V2. Now see, you know the potential of this path, you know the potential of this point, but you don't know the potential of this connecting branch. And what is this? This is actually the node. I am naming this node to be A, okay, to be A. And suppose the potential of this point is, I am considering it to be VA. Now, what is the function of KCL analysis? You can calculate the value of any branch current. How many branches are there? 3 branches. 1, 2, 3. And you can consider the current to be in any direction, whatever direction you want. Okay. Suppose in this path I am considering the current I1 to be in this direction. Okay. Going towards A, which means I am considering the V1 to be higher potential, because we know current flows from higher to lower potential. So we have considered V1 to be higher potential with respect to VA. And in this case, suppose I am considering the flow of current to be this I2 approaching A again. It means I am considering this V2 to be higher with comparison to VA, because we know current flows from higher potential to lower potential. And suppose this branch current I3, I am considering it to be in this direction. It means what is the potential of this point? 0 volt, because it is grounded. And what is the potential of this point? That is VA. So I am considering the VA is greater than 0 volt. That is why the current is flowing from VA to 0 volt. Now write applying KCL at node A. Okay. So at node A, I am, forget about the resistances, the batteries, just only think about the direction of the currents. Okay, this is the point A. So I1 current is approaching, I2 current is also approaching, and I3 current is going out, just like this. Okay, I1 current approaching, I2 current approaching, and I3 current is going out. So from the statement of KCL, I can write like, I have using the sign convention, the incoming currents to be positive and outgoing currents to be negative. So I can write like I1 plus I2 minus I3 equals to 0. Okay, this is the actual form of this circuit, that I1 and I2 currents are incoming and I3 current is outgoing. Now to calculate these values, you have to convert these currents in terms of voltage. How can you do this? So in this case, you have to approach the branch-wise approach. Okay, you have to consider the branch-wise approach. See this branch. Okay, the potential of this point is V1, potential of this point is VA. In between them there is a resistance. Okay, I am drawing this path here, the resistance R1. This point V1, I am writing V1. Okay, and this point VA, this is VA, and the current between them is I1. Now tell me, what is the potential difference here? Potential difference, I said higher potential is V1 and lower potential is VA. So potential difference will be V1 minus VA. How do you know that? Because the current is flowing from this to this direction. So V1 should be higher and VA should be lower. And I said from Ohm's law that if V is equals to IR, then I is equals to V by R. V means potential difference by resistance. Here the potential difference is V1 minus VA. And what is the resistance here? This is R1. So the current I1 means V1 minus VA, potential difference divided by the resistance of the path I1. This is equals to I1. So I1 equals to V1 minus VA by R1. Now I am considering, suppose, this path. Okay, see the resistance R2. Okay, this terminal V2 is this, and this terminal VA is this. So VA, and the direction of current is like this, from left to right, and the current is I2. Okay, if the current is moving from left to right, right to left, it means V2 is higher potential and VA is lower potential. So again the potential difference will be higher, V2 minus VA, divided by, what is the resistance? R2. Okay, and the current is I2. So I2 equals to V2 minus VA by R2. Okay, V2 minus VA by R2, and one more branch is remaining, that is this branch. Okay, so R3. Now see, this is VA, so this is VA, and this is 0 volt, this is 0 volt. So what will be the potential difference? Acha, the flow of current is like this, I3, So maybe this is higher potential, this is lower potential. Okay, and again I am saying these are my assumptions. Okay, it may be wrong also. So sir, what will happen if my assumptions, the directions of assumptions are wrong? Then the magnitude will be negative, and from the negative value you will understand that your assumptions are wrong. So if the value is negative, then you have to flip the direction. Okay, don't worry. So here the higher potential is VA and the lower potential is 0, because you have considered the direction of I3 from VA to 0. So what is the potential difference here? Potential difference is VA minus 0 divided by the path resistance is R3 is equals to what? I3. Okay, so see, I1 is equals to V1 minus VA by R1, I2 equals to V2 minus VA by R2, and I3 is equals to is VA minus 0 means VA by R3. So substitute I1, I2 and I3 by these values. Okay, so in place of I1 I have written V1 minus VA by R1. Okay, in place of I2 I have written V2 minus VA by R2, and in place of I3 VA minus R3. There was already a minus sign, that's why there is a minus sign. Okay, now imagine in the exam the values of R1, R2, R3 and V1, V2 will be given. So putting the values of V1, V2 and R1, R2, R3, you can easily calculate the value of this VA, right? So we will see a example. So is it clear? The concept should be clear. Okay, now see this example. The circuit is exactly like the previous. We have just mentioned the values. The V1 is 10 volt, V2 is 15 volt, R1 is 2 ohm, R2 is 3 ohm and R3 is 5 ohm. Now let us analyze the circuit again. Okay, now in this case I am slightly changing the direction of current. Okay, this point may be A, so the potential of this point I am considering to be VA. Okay, the direction of this path I am taking like this, I1, so I1 current is incoming, and this direction of current I am changing slightly, so I2 is going out from A, and this current is also going out. Okay, and one thing more, I said that the circuit should be grounded. Okay, so I am grounding this common port or common node, common port or common node, anything. Now see, by applying KCL at node A, the incoming current I1 minus outgoing current I2 minus outgoing current I3 is equal to 0, because algebraic summation should be 0. Okay, now analyze this batteries. Okay, this is 10 volt, minus plus minus plus. Okay, if this potential is 0 because it is grounded, if this is 0, then what will be the potential of this point? This point will be 10 volt, and the potential of this point will be 15 volt, because this battery will lift you up to 15 volt and this battery will lift you up to from 0 to 10 volt. This is the function of battery I have already mentioned. So see, in this case you have considered that 10 volt is higher than VA because current I1 is approaching from this to this, and in this path you have considered VA is higher than 15 volt because current is moving from this port to this port, and in this case you have considered the VA to be greater than 0 volt because current is moving from A to ground, right? Okay, some student may ask that sir, how is it possible you have considered VA to be less than 10 volt, but it is now, and here you have considered that VA is greater than 15 volt. How? See, it is my assumption, it is my consideration. Okay, you can consider any other thing, but don't try to sense it. Just apply the formula, and if your assumption is wrong, then the value will be negative, so you can flip the direction. Don't worry. Now just write this I1, I2, I3 in terms of potential difference. Okay, so look in this branch, 10 to VA. So what is the potential difference? This is in place of I1 I can write potential difference is 10 to VA. So the potential difference is 10 minus VA divided by what is the branch resistance? This is 2. So potential difference by resistance from Ohm's law minus this minus. Okay, now I2, which I2 is this path. See, so I have shown this path only, okay, because the direction is changed here. I2 is moving from VA to 15 volt. So VA is higher voltage and 15 volt is lower potential. So what is the potential difference? VA minus 15 divided by what is the resistance here? 3. So this is equals to I2. So in place of I2, VA minus 15 by 3. Okay, minus now I3. I3 is moving from point A to this ground. Okay, what is the potential of point A? There is VA, and what is the potential of this point? 0. So potential difference will be V minus 0 divided by what is the resistance? 5 ohm. So write 5 equals to what? 0. So see, in this equation only you have to calculate this VA. Okay, the denominators are 2, 3 and 5. So I have considered the LCM to be 30. Okay, I am not going to explain this calculation because I think you're able to do it. Okay, so 15 into 10 minus VA minus 10 into VA minus 15 minus 6 VA. So I am multiplying this 30 into this 0. I am moving into the right hand side. So 30 into 0 will be to 0. So it will be only, so 15 into 10 minus VA minus 10 into VA minus 15 minus 6 VA. So calculate VA. So sorry, in this problem I have to change this value by something. Okay, suppose I am considering this to be 12 volt. Okay, 12 volt. Okay, not required. It's okay, 10 volt is okay, no problem. 10 volt is okay. So voltage potential VA is coming 300 by 31, which is equals to 9.67 volt. Now see, I have taken an arbitrary example, okay, from my mind. That is why the value is little weird, but you will get a good example in the exam. So the value will be maybe round figure. Okay, don't worry about it, but it is also okay, 9.67 volt. Now see, the question is calculate the branch current, which means you have to calculate I1, I2 and I3, which is very simple. See, what is I1? I1 means what? I1 means 10 minus VA divided by 2. So 10 minus, what is the value of VA? 9.67 by 2. What is I2? I2 is equals to, see, I2 is moving from this direction to this direction. So VA minus 15 divided by 3. So VA minus 15 divided by 3. Here VA minus 15 divided by 3. So value of VA is 9.67 minus 15 by 3. I will calculate it later. Okay, I3 current is moving from VA to 0. So VA minus 0 divided by resistance is 5. So VA is 9.67 minus 0 divided by 5. Now if I calculate these values, this will be, so the values are 0.165 ampere minus 1.77 ampere and 1.93 ampere. Okay, now see, the value of I1 and I3 are okay because these are positive, which means my assumptions are totally correct about I1 and I3. Which assumption? The direction, which means the direction of I1 is in this direction and the I3 is in this direction. But in case of I2, see, this value is negative, which means, this negative means the direction of my consideration is from VA to, from A to this point, which is wrong. The direction is not from left to right, it should be flipped, right to left. Okay, so my consideration is wrong here. Okay, now some of the students may think that, sir, is it wrong? Will I get the marks? Yes, you will definitely get the marks, don't worry about it. It's just your assumption. So now if you are saying that the value is negative, it means you are clarifying that your assumptions were wrong, but you have cross-checked it. Okay, so the direction will be opposite. Now see here, I am considering this point A again. My direction of I1 was true, okay, correct. So what is the value of I1? It is 0.165 ampere. Okay, we have considered the direction of I2 like this from left to right, but it is negative. That is why the direction should be incoming, which means now we can consider it to be 0.177 ampere. Sorry, it is 1.77 ampere. Okay, don't write negative again because you have already flipped the direction. And if you want to keep the minus here, then don't flip the direction. Okay, and here I3 is 1.93. Now to cross check whether you have done it correct or not, you just have to apply the KCL law here. See what is the incoming current. Incoming currents are 0.165 and 1.77. See, the total value of incoming current is 1.935, which is exactly equal to the outgoing current 1.93. Yes, the 5 is missing here because I have rounded it off. Okay, so I can say from this that the value of incoming current is equal to outgoing current. So the circuit which I have analyzed is totally correct. Okay, so thus we can cross check our analysis. So this is all about KCL. You can try various examples from various books, but this is the basic fundamental of KCL and KCL analysis. In the next lecture we will learn about KVL, which is Kirchhoff's voltage law.